Welcome back to the session 13 of the differential equation. In this session, we are discussing some problems on orthogonal trajectories. In the last session, we discussed about the orthogonal trajectories. We know that the orthogonal trajectories are the family of curves which are orthogonal to or perpendicular to the family of curves f of x y c is equal to 0. In there, we are treating f of x y is equal to 0 as equation number 1. We differentiate 1 and we will have a differential equation corresponding to 1, and after getting the differential equation, that is a first order differential equation, there exists y dash is there, and on that differential equation we will replace y dash as minus 1 by y dash. So, we will have a new differential equation. That new differential, we will solve that new differential equation. While solving that new differential equation, we will have a family of curves. We will have a family of curves. That family of curves are called orthogonal trajectories of equation number 1. This is our method or pattern as we discussed in the last session. I am inviting your attention to our example 3 on orthogonal trajectory. Find orthogonal trajectories of family of curves x minus c the whole square plus y square is equal to c square. X minus c whole square plus y square is equal to c square. Say, what about the curve? X minus c whole square plus y square is equal to c square are the set of all concentric circle with centered at x intercept is x minus c and y intercept is 0. So, we will have a collection of lines on centered at c0, So, with the radius c is there. So, we will have the circles with the centered at c0 with the radius c. That means the collection of all circles which are passing through origin with the radius c. So, we can have many circles on different radius are there. So, as we done earlier, we can differentiate 1. On step 1, we can differentiate 1 with respect to x. See what will happen here, 2 into derivative of x minus c is 2 into x minus c is there, and derivative of x is 1, derivative of c is 0, so as well as y square, that is 2y, as we are differentiating y with respect to x, therefore, its derivative y dash will be there and derivative of c equal to 0 is there. We have 2 on both sides. So, I am taking 2 outside, I am taking to the opposite side of right side, we will have x minus c plus y dash is equal to 0. I am taking, this is equation number 2. This equation 2 is a differential equation corresponding to equation 1. From here, from the first part we can have, we can find out this one, value of c from 1. I am taking from 1 I am taking x minus c whole square as a minus b whole square. So, x square minus 2 c x plus c square is there, and as well as plus y square is there is equal to c square. We can cancel c square and c square from here. So, we will have minus 2 c x. I am taking minus 2 c x as this side. For the convenience, I am writing 2 c x is equal to x square and y square on the left side itself, therefore, is equal to x square plus y square. So, from here we have c is equal to x square plus y square divided by 2 into x square plus y square divided by 2x. Say, we found the value of c, just I am keeping the value of c is to be here for the further use, x square plus y square divided by 2x. Then we have here in equation 2. 2 is the differential equation corresponding to equation 1. In 2 we can replace the value of c by x square plus y square equal to divided by 2x. So, what will happen? This equation 2 becomes x minus of x square plus y square divided by 2x plus y dash is equal to 0. See, I am taking this 2x to be here, therefore, 2x square minus x square, I am taking minus to be here also, minus y square whole divided by 2x plus y dash is equal to 0. 2x square, so we will have x square minus y square divided by 2x plus y dash is equal to 0. So, we replace our 2 as a new differential equation. In our new differential equation, we have x square minus y square divided by 2x plus y dash is equal to 0. I am taking this as equation number 3 is the also differential equation corresponding to equation 1. So, from here we have got a differential equation corresponding to 1. Just I am taking y dash as, I am taking this is to be here from 3 we have y dash, I am taking y dash is there equal to, I am taking this is to opposite side, therefore, minus sign will come. So, minus y square will be plus y square and minus x square will be plus x square will be minus x square divided by 2x is there, divided by 2x is there. Therefore, this is equal to, I am taking y to be here, therefore, y dash is equal to y square minus x square divided by 2 x y is there. And I would like to take instead of 3 as 4 as a differential equation. So, y dash is equal to y square minus x square divided by 2 x y. Now, our step 2 is over. Now, we will move to the next step. On the next step, what is actually we will do on to we replace y dash as minus 1 by y dash. See what will happen on that step. So, instead of y dash we replace in 4, therefore, our 4 becomes as y dash is changes to minus 1 by y dash and this side is equal to y square minus x square divided by 2 x y. See minus 1 by y dash is there, I am taking negative to be on that side, therefore, we will have by taking reciprocal also, therefore, this is equal to, so I am taking 1 by y dash is equal to x square minus y square divided by 2 x y. Taking reciprocal, what will happen? While taking reciprocal, we will have y dash is equal to 2 x y divided by x square minus y square. Now, the fifth one is a differential equation. That differential equation we got actually by replacing y dash as minus 1 by y dash in fourth equation. So, fourth equation is a differential equation corresponding to 1. Now, the fifth differential equation we got by replacing minus 1 by y dash instead of y dash. So, while solving 5, we will have a family of lines or curves in the plane which are orthogonal to 1, that should be the orthogonal trajectories of 1. So, actually we need to solve this. Our thought is that how we will solve it. So, I like to divide both numerator and denominator of the 5, both numerator and denominator of 5 by x square. So, we will have y dash is equal to divide both numerator and denominator by x square. So, we will have y dash is equal to So, in numerator we will have dividing x square we will have y by x is there 2y by x divided by x square by x square is 1 is there, y square by x square is there, y by x the whole square is there. Now, we are happy we can have a use the substitution method. Our differential equation is converted to that will be convenient to use the substitution method. So, I am taking put u is equal to y by x, put u is equal to y by x. See, I am taking this x to be here, therefore, y is equal to u x, y is equal to u x. So, we can differentiate both sides. This I am taking this as first function, this as second function, and differentiate both sides with respect to x, dy by dx is there, and u into derivative of x is 1 plus x into derivative of u, that is u dash into x. So, see in equation number I am taking this as equation number 6. See to your equation number 6, there we can replace y by x as u and y dash the dy by dx as u plus u dash x. Therefore, equation 6 we can rewrite equation 6 as equation 6 becomes as y dash, instead of y dash we replace this like this. So, y dash is equal to u plus u dash x is equal to 2 into we replace y by x as u, therefore, 2 u divided by 1 minus u square. I am taking this u to be opposite side, therefore, plus u will become minus u, therefore, we will have u dash of x is equal to 2 u divided by 1 minus u square minus u is there, and therefore, u dash x is equal to 2 u divided by, I am taking 1 minus u square to be here, multiply 1 into minus u, that is equal to minus u is there, minus u square into minus u, therefore, this is equal to plus u square is there, divided by whole divided by 1 minus u square is there. Therefore, u dash of x, I am replacing u dash as du by dx into x, and this is equal to 2 u minus u, that is u plus this is a u square into u, therefore, this is equal to u cube, u plus u cube divided by 1 minus u square. Now, we are happy we are able to separate this as parts of u as well as parts of x. So, we can replace, I am keeping u is equal to y by x is there for the further use, u is equal to y by x, that we have to replace later. So, this is we can rewrite as I am taking this dx x by dx, that I am taking to right side, I am taking this part to be left side. So, 1 minus u square is in numerator, 1 minus u square divided by u plus u cube in denominator, u plus u cube into du is equal to, I am taking dx to be numerator divided by x. Now, we are happy our variable separated form is there. This is a equation we generated from 6. This is we generated from equation number 6. Now, we can change we can solve this differential equation. So, we will have a solution in terms of u and x. After solving this differential equation, we can change the u as y by x. So, we will have a solution of a differential equation 6. The solution of differential equation 6, the 6 is generated from 1 by replacing y dash as minus 1 by y dash. That is why we will have a new family of curves that are orthogonal to 1. So, the solution of this will be orthogonal trajectories of 1. So, I like to integrate both sides, integrating. So, it will be integral of 1 minus u square divided by u plus u cube du is equal to integral of dx by x plus c. I am taking this as equation number 7. See, in 7 on the left side we have to make it as a partial fraction. So, how we will change as partial fraction? How we will change it as a partial fraction? So, I am taking 1 minus u square divided by u plus u cube as 1 minus u square divided by u into 1 plus u square. Just I am taking 1 u is out. So, we can rewrite this as a divided 1 minus u square divided by u into 1 plus u square, we can rewrite as a divided by u, plus the second part is a quadratic polynomial in u. Therefore, we will have b u plus c divided by 1 plus u square is there, 1 plus u square is there. So, I am multiplying the common denominator is there u plus u into 1 plus u square. I am multiplying this on both sides with the common denominator u into 1 plus u square. So, multiply with u into 1 plus u square is there. Therefore, what will happen? This is 1 minus u square is remains here as numerator. This will be cancelled with u into 1 plus u square, and this is equal to a into u into 1 plus u square is there. It will cancel u and u. The remaining is only the 1 plus u square, and plus b u plus c, both numerator both in numerator and denominator the term of 1 plus u square is there. The only remaining term is u is there. See, this is the final equation. From here we can determine the value of a, b and c, that we can apply here. From here we can use instead of this as these values, and you can solve this very easily. So, see, I am putting u is equal to 0, putting u equal to 0. See, what will happen? While putting u is equal to 0, 1 minus u square is 0, a into 1 plus 0, a into 0, that is a is there, b into the outside 1 u is there, 0 into b u plus c is 0, therefore, only a will be there. Therefore, a is equal to 1, we have got a is equal to 1. Now, see, compare, we have here there is no term of u is there, here is here there is no term of u is there, and but here is the term of u, b u u, that is u square is there, only the coefficient of u is c. So, I am taking compare coefficient of u. So, what will happen? Here there is no coefficient of u is there, that is 0. Here there is no term of u is there, that is for 0, plus here b u into u, that is u square, that is 0, only c is there. So, we have got the value of c as 0, value of c as 0. Now, we found a and c, it remains only to found b. How we will found b? Here b as a coefficient of u square, and as well as a is a coefficient of u square, here is a term of u square is there. So, compare coefficient of u square, compare coefficient of u square. So, here we have coefficient of u square as -1, this is -1 equal to coefficient of u square as a plus coefficient of v square, u square has in this term u into u square and into b is there, therefore, coefficient of u square is b is there. We already found the value of a, just I am replacing the value of a is here, therefore, this will be by replacing the value of a is 1 plus b is there. From here we will get b is equal to, I am taking this one to be here, plus 1 will be -1, therefore, b is equal to -2. So, we found the value of a as 1, c as 0 and b as -1, sorry, b as -2. Now, we can just replace that values to be here, therefore, we will have, see, this equation will be equal to a, instead of a, that is 1 minus u square divided by u plus u cube, we can replace as a divided by a as 1 by u plus b as minus 2. So, b as minus 2 u plus c as 0 divided by 1 plus u square. See, in equation 7 we can replace 1 minus u square divided by u plus u cube by this. So, equation 7 will be, in equation 7 integral of 1 minus u square divided by u plus u cube as integral of 1 by u plus, sorry I am taking minus is here. So, minus 2 u divided by 1 plus u square du is equal to integral of dx by x plus c. Now, we are happy we are able to solve this differential equation. So, we can write this as integral of 1 by u du minus integral of 2 u divided by 1 plus u square du is equal to integral of dx by x plus c. Now, we are able to solve this is integral of 1 by u, that is log q, and here see 1 plus u square is here. The derivative of 1 plus u square is 2 u, that is in numerator. Therefore, the derivative of denominator is in numerator, therefore, logarithm of denominator is the value of integral. Therefore, we can write this as logarithm of 1 plus u square, and here this is equal to log x. For the convenience I am writing the constant as log c. So, see log q minus log of 1 plus u square, log a minus log b as log of a by b. So, that is log q log of u divided by 1 plus u square is equal to log a plus log b log of a b. So, log of c x is there. So, we can replace taking exponential on both sides, we will have u divided by 1 plus u square is equal to c x. This is actually the solution of equation 7. This is actually the solution of 7. Now, we have to replace u divided by 1 by y by x. So, then only we will have the solution of 6 will come. Actually, we have to solve 6 for to get the orthogonal trajectories of 1. So, we will have we replace u by y by x. So, what will happen? This is y by x divided by 1 plus y square by x square is equal to c x. So, we will have y by x divided by, I am taking x square to be here, x square plus y square by x square is equal to c x. So, we will have, I am taking this x square to be numerator and x will cancel. Therefore, x y divided by x square plus y square is equal to c x. See, on both left side and right side there is an x is there, therefore, we will have, we can cancel this x and this x and this x from here. So, after all we will have y divided by x square plus y square is equal to c. For the convenience I am taking this denominator to be on the right side. So, we will have y is equal to c into x square plus y square. Now, this is the final solution of equation 6, and as well as this is a final solution of equation 6. We have got equation 6 from the 1 by replacing y dash as minus 1 by y dash. Therefore, y is equal to c into x square plus y square is a orthogonal trajectory of equation 1. See, there are many examples we can solve to find as an orthogonal trajectories. Next we will move to another example, that is very nice example to discuss, as the orthogonal trajectory of the family of ellipses. I am moving to the next example, example 4. Show that the family of ellipses x square divided by a square plus c plus y square divided by b square plus c is equal to 1 are self orthogonal That means where a, b are constants and c is the arbitrary variable that we are treating c as a variable. See here in this question we have to show that this is an equation of ellipse. This is actually an equation of ellipse. We have to show that this is self orthogonal. That means orthogonal trajectory of this family of ellipses are the same family itself. So, it is enough to show that we can find out the differential equation corresponding to this family of ellipses. I am taking this as equation number 1. In the family of ellipses, we are forming the differential equation, and again after getting differential equation, we replace y dash as minus 1 by y dash. See, if again we will get a differential equation of same differential equation, then we can say that they are self orthogonal. So, that means the differential equation corresponding to curve 1 and the orthogonal trajectory are the same, therefore, they are self orthogonal. So, I am moving to the differentiate this one. While differentiating one, we will have derivative of x square is 2x divided by a square plus c plus 2y, derivative of y square is 2y, as we are differentiating y with respect to x, so 1 y dash is there, b square plus c equal to 0. So, from here we will have I am taking 2 and 2 out and taking to the right side, denominator of the right side, we will have it is equal to 0, x into b square plus c plus y dash into a square plus c equal to 0. I am taking this is as equation 2. Equation 2 is the differential equation corresponding to 1. From here we are able to find the value of c. Listen, from here I am taking x to be inside, therefore, we will have x b square plus c x plus y dash a square plus c into y dash equal to 0. I am taking the terms containing c as common, therefore, c into x plus y dash, and I am taking all other things to the right side, therefore, minus of everything is positive, therefore, minus of x b square plus a square y dash. So, from here we can find the c is equal to minus of x b square plus a square y dash divided by x plus y dash. See, we found the value of c. As c is equal to minus of x b square plus a square y dash divided by x plus y dash, that we have to use later. So, from there we can find the value of a square plus c. that is equal to a square plus c as c is equal to minus of x b square plus a square y y dash divided by x plus y y dash. Therefore, a square minus of x b square plus a square y y dash divided by x plus y y dash. See, we have this is equal to, I am taking this is to be here cross multiplying. So, we will have a square x plus a square y y dash by taking negative to out inside. Therefore, minus x b square minus a square y y dash divided by x plus y y dash is there. See, here plus a square y y dash is there, minus a square y y dash is there. After all, we will have a square plus c, we will have a square plus c. A square plus c is equal to a square plus c is equal to a square minus b square. In both there is x is common, x divided by the denominator is there, the denominator is x plus y y dash is there. So, we found a square plus c. I am taking a square plus c also is here, that a square plus c is here, that is also we have to use later, that is a square minus b square into x divided by x plus y y dash is there. Now, again as we found a square plus c, I like to found b square plus c. I like to found b square plus c. Why I am finding a square plus c and b square plus c? I like to found a new formula for this equation 1. So, a square plus c is equal to, and as well as I am trying to find out b square plus c, that is equal to b square plus, we know that the c is the minus of x b square plus a square y y dash divided by x plus y y dash is there. I am taking this is to be here. So, we will have b square x plus b square y y dash minus x b square minus of a square y y dash divided by x plus y y dash is there. See, here we have plus b square x, here we have minus b square x is there. So, b square plus c, we will have b square plus c is equal to, b square plus c is equal to, this is y y dash is common here. So, b square minus a square divided by into y y dash divided by x plus y y dash is there. So, we found b square plus c also. Now, we found b square plus c. So, I am writing this is as equation number 2, that we also have to use b square plus c equal to b square minus a square into y y dash divided by x plus y y dash, x plus y y dash is there. Now, see, we found a square plus c as well as b square plus c, we will put these all values in 1. I am taking equation 2 also is there inside, x into b square plus c plus y y dash into a square plus c equal to 0, y y dash into a square plus c equal to 0. This is equation number 2. We put a square plus c and b square plus c in equation 1. See, what will happen? Our equation 1 will become x square divided by a square plus c as a square minus b square into x divided by x plus y dash, and plus y square divided by, instead of b square plus c we can write as b square minus a square into y dash divided by x plus y dash equal to 1, equal to 1. See here I am taking this x plus y dash is common in both side, in both there is a common denominator, the denominator of denominator is in numerator, therefore I can replace x plus y dash is in numerator, and I am taking this as x square by x, will have x is there, x divided by a square minus b square is there. I am taking one negative is outside, therefore this is minus, and therefore because of minus this b square minus a square is a square minus b square itself, and instead of we can cancel 1 y and y from here, this is numerator 1 y is there, in the denominator 1 y dash is there, is equal to 1. So, I am taking x plus y dash is there, and here x a square minus b square is common in both sides in the denominator, therefore again we can replace x plus y dash into x minus y divided by y dash. I am taking this common denominator a square minus b square into right side, this is equal to a square minus b square. I am taking this as a new equation, and I am taking this as star. See the star containing the differential derivatives y dash is there, first order derivatives there. So, simply we can say that star we found star from 1, and 1 is the collection of all ellipses, the family of ellipses. And see, while solving this I am just replacing, this is now differential equation we generated from 1, and just I am replacing y dash as minus 1 by y dash in star the differential equation corresponding to 1, and what will happen it is that x plus y dash is replaced by minus 1 by y dash, therefore y into y dash as minus 1 by y dash, this is equal to x minus y divided by y dash, and again x minus, and this minus 1 by y dash is there, I am replacing y dash as minus 1 by y dash, this minus and minus will be plus, 1 by y dash is in numerator, therefore y dash is there equal to x square a square minus b square. And see, this is as I am taking this as star dash. Compare star and star dash. See, star we derived from 1, 1 is the collection of all ellipses, and here x plus y dash is there in left side, that is also here, and x minus y divided by y dash is there, that is also here, and as well as in the right side a square minus b square is there. So, actually what is the fact is that star is equal to star dash, star is equal to star dash, and star is a differential equation derived from 1, and this is a differential equation we have got by replacing y dash as minus 1 by y dash. Both the differential equations are same. Therefore, we can say that we can say that one is self orthogonal. Self orthogonal. That means the collection of all ellipses of the form x square by a square plus c, y square by b square plus c is equal to 1, where a, b are constant and c is a variable, are the self orthogonal collection of all family of lines. So, we can find many problems, very interesting problems on the orthogonal trajectories. Now, I like to stop this session to be here. Thank you for watching this video. Continue your watching. Thank you very much.